Consider the vectors A equal to 3i plus 2j plus ak and b equal to minus I plus j plus 4k are orthogonal. Then find the value of A. Suppose two vectors are orthogonal, then their dot product should equal 0. A dot b equal to 0 if A and B are orthogonal. You know that A dot b equal to AB cos theta. If theta is 90 degree, then cos 90 equal to 0. So if these two vectors are perpendicular to each other, the A dot b equal to 0. Here 3i plus 2j plus ak dot minus I plus j plus 4k will equal 0. Minus 3 I dot I 1. So minus 3 plus 2 plus a into 4. 4a equal to 0. Here 4a minus 1 is equal to 0. Then 4a equal to 1, a equal to 1 by 4. If the vectors a and b are mutually orthogonal, the value of a should be 1 by 4. Now we will go to the second problem. The position vector, problem number 2, the position vector in Cartesian coordinates is r equal to xi plus yj. What is this vector in cylindrical coordinates? Here, the position vector in Cartesian coordinates is given. It is r equal to xi plus yj. Now we have to find out the position vector in terms of cylindrical coordinates. In cylindrical coordinates, x equal to r cos phi and y equal to r sin phi. Now vector r is equal to x into I, that means r cos phi into I plus r sin phi into j, that is y into j. This is equal to, take this r outside, cos phi into I plus sin phi into j. This is r into r cap. Cos phi into I plus sin phi into j is a unit vector. So the vector r is equal to r into r cap. This is value of position coordinate in cylindrical coordinates. I will go to the third problem. problem 3. Which of the following is not orthogonal curvilinear coordinate system? Coordinate system. Option A, cylindrical coordinates. Option B, Cartesian coordinates. Option C, spherical coordinates. Option D, polar coordinates in 3 dimension, in 3D. Orthogonal curvilinear coordinate system is a system in which the coordinate surface intersect at right angles. The coordinates are not necessarily straight lines. The basic vector at each point are mutually perpendicular. If you think about the polar coordinates, they are defined only in 2 dimensional, that is in terms of r, theta. You can't extend the polar coordinate directly to 3 dimension without converting to cylindrical or spherical. Therefore, option D is correct. Which of the following is not orthogonal curvilinear coordinate system? Polar coordinates in 3 dimension are not orthogonal curvilinear coordinate system. Now we will go to the 4th problem. Green's theorem, problem number 4. Green's theorem relates a line integral to a surface integral over a region R if f is equal to p comma q, which is equal to minus y comma x, then what is integral f dot dr for a unit circle? Now we have to utilize our Green's theorem. Integral f dot dr, which is equal to double integral of dou q divided by dou x minus dou p by dou y into dx dy. We have to use this. This is a Green's theorem. F dot dr is equal to dou q by dou x minus dou p by dou y into dx dy. In the given problem, dou q by dou x. See here. Dou q p comma q equal to minus y comma x. Now you have to find out the values of dou p by dou y and dou q by dou x. Dou q by dou x equal to 1. See here. This is in terms of p, this is in terms of q. Dou q by dou x equal to 1. Then dou p by dou y equal to minus 1. Now substitute these two values here. Double integral dou q by dou x 1 minus of dou p by dou y is minus 1 into dx dy, which is equal to 2 into dx dy, which is 2 into area. See here, if you consider a circle, the area is pi r square, but here we are concentrating on unit circle, therefore the value of r equal to 1. So the answer is 2 pi. Actually area is pi r square. Here we are concentrating the unit circle, so radius is 1. So 2 pi is our answer for this problem. Now we will go to the next one. That is the fifth problem. F is equal to p comma q, which is equal to x square xy. Use Green's theorem to evaluate f dot dr, where c is a contour, unit square bounded by x equal to 0 comma 1 and y equal to 0 comma 1. Now you have to use our theorem, that is integral f dot dr, which is equal to double integral of dou q by dou x minus dou p by dou y into dx dy. Here the value of dou q by dou x in our problem, dou q by dou x. See, dou q by dou x is given to you. See here, p comma q equal to x square comma xy. So again we will check the problem. X square comma xy. Yes, it is correct. Now find out dou q by dou x, that is y. Then dou p by dou y is equal to 0. See here, this is p. P is x square. Dou p by dou y equal to 0. Now f dot dr equal to dou q by dou x, that is y, minus of dou p by dou y 0 into dx dy. Here 0 to 1, 0 to 1. Now this is 0 to 1 y dy, 0 to 1 dx. Integral of dx is x. If you apply the upper limit 1, this is equal to 0 to 1 y dy, which is equal to y square by 2, limit varying of 0 to 1, which is equal to 1 by 2. If you apply the upper limit, 1 square is 1 divided by 2. So this is the answer. 1 by 2 is the answer for this problem. We will discuss the rest of the things in the next lecture. Thank you.